Hello students, today I am going to start a new chapter, that is integration. So first of all we will give some brief introduction related to the integration. So what is integration? So point number first, that is what is integration? Basically the integration is the reverse process of differentiation. So integration is the reverse process of differentiation, and the point number second, from differential calculus we know that a dy by dx of f of x means if the differentiation of the function f of x is capital F of x, then inversely we can say integration of f of x with respect to x is small f of x. So which implies integral of f of x with respect to x is f of x plus c, where c is the integral constant. Where c is the integral constant. So we know that differentiation of f of x is equal to f of x, capital F of x. Then inversely we can say integration of f of x dx is f of x plus c, because the point number 1 says integration is the reverse process of differentiation. For example, we know that differentiation of e power ax is a into e power ax. In other words, we can say integration of a e raised to power ax dx is e raised to power ax, because integration is the reverse process of differentiation. So in this chapter, first we will learn standard forms of integration, what are the standard forms of integration, and second one, what is the geometrical meaning of integration. Also we know that differentiation of log x is 1 by x. So in other words, we can say integration of 1 by x with respect to x is log of mod of x plus c, where c is integral constant. So from this definition, derivative of f of x with small f of x with respect to x is capital F of x. So we can say here integration of f of x dx is small f of x plus c, where c is the integral constant. Dear students, here we have some functions. Here differentiation of x raised to power n, we know that this is nx power n minus 1. Here we can say integration of nx raised to power n minus 1 dx is x raised to power n, means if we integrate this function with respect to x, we will get x power n, because differentiation and integration are inversely each other, or we can say integration is the reverse process of differentiation. Here differentiation of e raised to power x, we know that is e raised to power x. Thus we can say here integral of e raised to power x with respect to x is e raised to power x plus c. Here there is also c, and differentiation of cos x is sin x. Here we can write here integration of sin x dx is equal to cos x plus c. As we know that the differentiation of a raised to power x is a raised to power x into log of a, which implies integration of this integration of a raised to power x with respect to x is a raised to power x divided by log of a plus c. And also we know that differentiation of sine inverse of x is 1 divided by square root of 1 minus x square. So we can say here integration of dx divided by root over 1 minus x square is sine inverse of x plus c. Also we know that differentiation of tan inverse of x is 1 divided by 1 plus x square. So we can say here integration of dx divided by 1 plus x square is tan inverse of x plus c. From these functions we also observe that integration is the reverse process of differentiation, because differentiation of x power n is nx power n minus 1. If we integrate this function, we will get x raised to power n. Here, as we know, the differentiation of cos x is sin x. So if we integrate sin x with respect to x, we will get sin x, or if we integrate sin x with respect to x, we will get cos x plus integral constant c. From these functions, we learn here that integration is the reverse process of differentiation. Now, what is the geometrical meaning of integration? So geometrically, the meaning of integration is, this is particularly indefinite integration. We are not talking about the definite integration. This is indefinite integration. Geometrically, the term indefinite integration represents the family of curves. So this represents the family of curves. Geometrically, the indefinite integration represents the family of curves. For example, we know that differentiation of 2x plus 1, say differentiation of x square plus 1. We know the differentiation of x square plus 1 is 2x. Differentiation of x square plus 1 is 2x, because we know the differentiation of 1, that is the constant, and the differentiation of constant is 0. So we can say here integration of 2x dx, integration of 2x is 2 times integration of x dx, which is 2, and integration of x is x square divided by 2 plus c, which is x square plus c. So actually the integration of 2x dx is x square plus c. Now here the differentiation of x square plus 1 is 2x. If we say here dy dx of x square plus 2, this is same as 2x, and differentiation of dy dx of x square plus 3, which is same as 2x. Now here the differentiation of x square plus 1 is 2x. Thus we can say integration of 2x dx is x square plus c. Now if we integrate here, again integration of 2x dx, which is again x square plus c, and here integration of 2x dx is x square plus c. Now here the x square plus 1, differentiation of x square plus 1 is 2x, differentiation of x square plus 2 is 2x, x square plus 3 is 2x. Here the integration of 2x is x square plus 1, if we say here x square plus 1, integration of 2x, x square plus 2, integration of 2x here is x square plus 2, that is why we write here c, because we know that the differentiation of constant is 0. So this is here arbitrary constant. This c is arbitrary constant. It may be 1, it may be 2, it may be 3, and more particularly this is known as integral constant. Let's sketch the graph of this function. So what is geometrical meaning of integration of 2x dx? Actually, the graph of 2x dx will be x square plus c. It may be x square plus 0, it may be x square plus 0, it may be x square plus 1, it may be x square plus 2, so on. It may be x square minus 1. So here we observe that the integration of any function represents the family of curves. Here the integration of 2x dx represents the family of parabolas. But the interesting thing is here, if we draw the tangent of any curve here, say x square plus 2 at any point, say at x is equal to 1, x is equal to 1, if we sketch here the tangent of this, say this, and the slope of these tangential lines is equal. Here the slope of these tangential lines is equal. But you have to remember the geometric meaning of indefinite integration. The geometric meaning of indefinite integration represents the family of curves. So integration of 2x dx is x square plus c. So here c may be 0, here c may be 1, here c may be 2, it may be minus 1, minus 2. So it will represent the family of curves. So this is the geometrical meaning of indefinite integration. So geometrical meaning of indefinite integration is the family of curves. So in point number first, there is only one sentence that you have to remember, that is integration is the reverse process of differentiation. And in the second point of the integration, that is you have to remember what is the geometrical meaning of integration. The indefinite integration. So the geometrical meaning of indefinite integration is the family of curves. Now the third point of integration, that is you have to remember some standard formulas, or in other words we can say these are the basic formulas of integration. You have to remember these formulas. So formula number 1, integration of x raised to power n dx means integration of x power n with respect to x is x raised to power n plus 1 divided by n plus 1 for all n is not equal to minus 1. So this is the first basic formula of integration, that is integration of x raised to power n, where n may be any number, is equal to x raised to power n plus 1 divided by n plus 1. For example, if you have to integrate integration of x raised to power say 10 dx, so you have to apply this formula here. So the formula says integration of x raised to power n dx is x raised to power 10 plus 1 divided by 10 plus 1 plus integral constant c. Because from the previous point, that is the geometrical meaning, integration of x raised to power 10 dx will represent the family of curves. That is why we write here c. So that is x raised to power 11 divided by 11 plus c. So this is the integration of this. So point number 2, this is not actually the point number 2, but this is the sub concept of this x raised to power n, that is integration of k into x raised to power n dx is equal to k into x raised to power n dx, which is equal to k into, what is the integration of x raised to power n? That is x raised to power 11 divided by 11 plus, sorry, this is x raised to power n plus 1 divided by n plus 1 plus c. For example, you have to integrate integration of 3x raised to power 4 dx. So its integration is 3 into integration of x raised to power 4 dx is 3 into, what is the integration of x raised to power 4? So use this basic formula, that is x raised to power 5 divided by 5 plus c, which is equal to 3 by 5 x raised to power 5 plus c. So this is the first basic formulas, and this is the sub concept of first basic formula. Now the third point is, here from the first point we learned integration of x raised to power n dx is x raised to power n plus 1 divided by n plus 1 plus c. Now if we replace this x by linear term, that is ax plus b, what we get? So integration of ax plus b power n, its integration will be same, use the same rule here, that is ax plus b raised to power n plus 1 divided by n plus 1 internal differentiation of ax plus b. So we know that differentiation of ax plus b is a. So put this a in denominator plus c. Why? This concept we will learn by the second topic, that is integration of substitution. Why this a put in denominator? Now for example, we have to integrate integration of 3x plus 2 raised to power 4 dx. So direct way of finding the integration of this is 3x plus 2 raised to power 4 plus 1, that is 5, divided by 5 into internal differentiation of this 3x plus 2, that is 3 plus c, which is 1 by 15 3x plus 2 power 5 plus c. So this is the second formula. Now the third formula is integration by 1 by x dx. As we know that differentiation of log x is 1 by x, thus we can say integration of 1 by x dx is log of mod of x. So we can say here integration of 1 by x dx is log of mod of x plus c. Now if we replace this x by ax plus b, what we get? We will get integration of 1 divided by ax plus b dx is. Here we replace x by ax plus b, we will get here log of modulus of ax plus b into internal differentiation. And we know that internal differentiation of ax plus b is a, so divided by a plus c. Because in differentiation, the internal differentiation is multiplied by the function. Now, because this is the reverse process, that is why we divide by function by its internal differentiation. So this is the point number 2, formula number 2, formula number 3. Now let's take an example related to this concept. So example is, what is integration of 1 by 2x plus 3 dx. So you have to apply this rule here. So the direct way of finding the integration of this is log of modulus of 2x plus 3 divided by 1 by 2, because the internal differentiation of 2x plus 3 is 2 plus c. Now another important point, that is integration of 1 by x square dx. So if you have to integrate this function, integration of 1 by x square, so rewrite this function in the form of integration of x raised to power minus 2 dx, and use the first rule of differentiation. Use the first standard formula of this function, that is integration of x raised to power n dx. So its integration will be x raised to power minus 2 plus 1 is minus 1 divided by minus 1 plus c, which is equal to minus 1 by x plus c. Now if we integrate this function, integration of 1 divided by ax plus b whole square, rewrite this equation in this form, integration of ax plus b power minus 2 dx, and use the second formula, that is this is equal to ax plus b power minus 1 divided by minus 1 into internal differentiation of ax plus b is a. The final result will be minus 1 by ax plus b raised to power minus 1. Or we can say this is equal to minus 1 divided by a into ax plus b plus c. For example, if you have to integrate integration of, what is the integration of 2x plus 1 whole square, so you may write this function in the form of integration of 2x plus 1 power minus 2 dx, that is equal to 2x plus 1 raised to power minus 1, because minus 2 plus 1 is minus 1 divided by minus 1 into internal differentiation of 2x plus 1, that is 2. So result is minus 1 by 2 into 2x plus 1 plus c. Now the next formula is integration of e raised to power x dx is in e raised to power x plus c. As we know that the differentiation of e raised to power x is e raised to power x, so we can say integration of e raised to power x is again e raised to power x. Now if we replace this x as ax plus b, so integration of ax plus b dx will be, so as we know that e raised to power, integration of e raised to power x is e raised to power x, right here e raised to power ax plus b, and the internal differentiation of ax plus b is a, so divide this by a plus c. For example, if you have to integrate integration of e raised to power 2x plus 1 dx. So right here e raised to power 2x plus 1 divided by the internal differentiation of 2x plus 1, that is 2 plus c. Now let's take another example, that is, if you have to integrate e raised to power minus 2x plus 1 dx, then directly the integration of this function is e raised to power minus 2x plus 1 divided by the internal differentiation of minus 2x plus 1, that is minus 2 plus c. This is the procedure how to find the integral of e raised to power x. Now the fourth formula is integration of a raised to power x dx that is in a raised to power x divided by log a plus c, because we know that the differentiation of a raised to power x is a raised to power x into log a. So we may write this 1 divided by log a. Differentiation of a raised to power x is a raised to power x. So we can say here integration of a raised to power x dx is a raised to power x divided by log a. Now if we replace this x by ax plus b, what will happen? Integration of a raised to power say here mx plus b is equal to a raised to power mx plus b divided by log a into internal differentiation of mx plus b, that is m. So final result will be 1 divided by m log a raised to power mx plus b plus c. Now let's take the example. Integration of a raised to power 2x plus 1 dx, that is equal to a raised to power 2x plus 1 divided by, apply this rule here, divided by log of a, log of base, here this is log of base, into internal differentiation of 2x plus 1, that is 2 plus c. So final result is 1 divided by 2 log a raised to power 2x plus 1 plus c. This is the procedure how to find the integration of a raised to power x. Now let's take another example, that is, what is the integration of 2 raised to power x, 2 raised to power 3x plus 1 dx. So this is of the form of this a raised to power x dx. So its integration is 2 raised to power 3x plus 1 divided by log base, log of 2, here the base is 2, and into internal differentiation of 3x plus 1, that is 3 plus c. Now what is integration of 1 dx? So this is equal to integration of x raised to power dx, because we know that x raised to power 0 is equal to 1. This is equal to x raised to power 0 plus 1 divided by 0 plus 1 plus c, which is equal to x divided by 1 plus c, which is equal to x plus c. So integration of dx is x plus c. What is integration of sin x? So the integration of sin x, you know that this is minus cos x plus c. So if we replace this x by ax plus b, what will happen? So integration of sin ax plus b dx will be equal to minus cos of ax plus b into internal differentiation of ax plus b, that is a, divided by a plus c. For example, if you have to integrate sin 3x plus 4 dx, you can directly write here integration of sin x is here minus cos of 3x plus 4 divided by internal differentiation of 3x plus 4, that is 3 plus c. Now, another point is integration of cos x dx, that is sin x plus c. Similarly, if we replace x by ax plus b, what will happen? Integration of cos of ax plus b, so integration will be sin ax plus b divided by a plus c. Now the another point is integration of sec square x dx is tan x plus c, the direct formula, because we know that differentiation of tan x is sec square x. So integration of sec square x will be tan x. Now, if we replace here x as ax plus b, what will happen? Integration of sec square ax plus b dx is equal to tan of ax plus b divided by internal differentiation of ax plus b, that is divided by a plus c. For example, if you have to integrate sec square 2x plus 1 dx, so direct integration of this function is tan 2x plus 1 divided by 2 plus c. Now another point is integration of cosec square x dx is minus cot x plus c. Now if we replace here again x by ax plus b, then integration of cosec square ax plus b will be minus cot ax plus b divided by a plus c. Integration of sec x tan x. What is the integration of sec x tan x? That is sec x plus c. Now What is the integration of cosec x cot x? This is equal to minus cosec x plus c. So these are the direct formulas. You have to remember these formulas and apply the same procedure by replacing x is equal to ax plus b. Now, what is the integration of tan x? Actually, this is the not standard form of integral. This function we will discuss in another part of lecture. What is the integration of tan x? But you have to remember this point here. Integration of tan x is log of modulus of sec x plus c. We will discuss in when we take the integration by substitution. So what is integration of cot x dx? This is equal to log of mod of sin x plus c. So integration of sin inverse of x. Sorry, actually this is integration of 1 divided by root over 1 minus x square dx, because we know that differentiation of sin inverse of x is 1 divided by root over 1 minus x square. So we may write here integration of 1 divided by root over 1 minus x square is sin inverse of x. Similarly, integration of minus 1 divided by root over 1 minus x square dx is cos inverse of x plus c. And integration of 1 divided by 1 plus x square dx is tan inverse of x plus c. And integration of minus 1 divided by x square dx is minus, this is cot inverse of x plus c. So these are the directed formulas. You have to remember these formulas, and we have to apply these formulas in other parts of the lectures. That is all for the today's lecture.